Go. Hello and welcome back to Calculus 1, section 2.3 on computing limits. Techniques to computing limits. The title in the book is longer. So, how do we compute limits? We know what they are. Y values of the function. We know how they're different than computing pre-calculus, right? Pre-calculus computes at the point. Limits compute everywhere around the point except at the point, and then infers the answer. So what are the methods? Why is this orange? What are the methods? Well, number one, graph. Generally, if the graph is available, you look at the graph, you make your claim, and you walk away. Well, graph might not be always available. The second method we covered was table or chart of values. Chart of values. I call this middle school method, right? Where you pick your x's, compute y's. Well, we picked values that were going towards the number we need, getting ever closer to it. Compute the y values, look at the trend, use the theorem. If they are pushing towards the same number, like we had 8 and 8, I believe, then the limit is 8. If they are pushing different numbers, 2 and negative 1, or whatever it was, then no limit. So you can detect that through the chart. Now, since the chart is annoying, we can also use algebra. Now, what are the algebra methods that we get to use? Well, we can use factoring. We can use canceling. Well, let's go with reducing. Reducing expressions, canceling, but still reducing expressions. C. So factoring, reducing, rationalizing. The scary method, I should have placed this one as A, is plug in. I have to put warning over there. Be careful. Maybe there are some identities you can use. Let's say you run into trig. Sine 2x is equal to 2 sine x cosine x. Maybe. So these are the methods. The first one I have to address is the dangerous one, plug-in. Because clearly you will always resort to this one first, and if this doesn't work, you have to move on and look for other stuff. Which is why I should have listed this as A, but whatever. So plug-in method. If we go to the previous lecture, you remember that I solved the y value of the function using pre-calculus by plugging in 3 into the function. There was no limit there anywhere, right? And I got 8. Then we did calculus version of this, and we got 8. So in many cases, the pre-calculus value and the calculus value match. So at any point on the graph where you have a continuous line, the smooth line, pre-calculus will align with calculus, meaning that you can just solve the limit by plugging the value in. But in other cases, you are going to plug the value in and you are going to get 0 in denominator. And in that case, you cannot plug in. You have to use other methods. So plug in. Let's put some examples when it works just fine. Say limit x goes to 5 of x squared plus 3. Well, this one you can compute as 5 squared plus 3 equals to 28, and you're done. Limit of sine x as x approaches pi over 3. Okay, well that's sine pi over 3, which is very good. All right, so root 3 over 2. I gave you enough time. So these are examples where plug-in method works. Method works. And we're happy. But then you run into these problems where it doesn't. Limit x goes to 2, 1 over x minus 2. What happens as you plug in 2? Yes. This is known as explosion, and we'll see why. So, method does not work. So method doesn't work. Let's take another case. Limit x goes to 3 of x minus 3 divided by x squared minus 9. Wouldn't this be 0 divided by 0? Yes?
That's a difference exponent, right?
Yes. So when you plug in, wouldn't you get 0 divided by 0? You would, right? How much is that? Well, you say 0, she has undefined, so what? Take it outside or something? Or we can be civilized and settle the score. How about I tell you what 0 divided by 0 is? How about 1 over 6? You never heard of that? 0 divided by 0 is equal to 1 over 6? Okay. Yeah, welcome to calculus. So method doesn't work. So what should we do if the method doesn't work? Well, we have a lot of other methods. Your graph, your chart of values, or maybe we can use algebra. So how about I pick up this problem here and say limit x goes to 3 of x minus 3 over x squared minus 9, and we use the knowledge that we have difference of squares in denominator. Can I factor that? Great. And then what I'm able to do when I factor? I'm able to cancel. Boom! So now what happens? Ah! Magic! Yeah, they used to burn people for this. Now we're just like, yeah, you divide 0 by 0, you get 1 over 6. It's clear, right? So next time someone tells you, what do you know? 0 divided by 0 is 1 over 6. What do you know? Now clearly the answer for 0 divided by 0 will depend on which functions I have. Because if I have x minus 5 divided by x squared minus 25, the answer would be 1 over 10 for 0 divided by 0. So it is dangerous business to memorize divided by 0 limit does not exist, right? Because I am going to agree with you In this example, that limit does not exist. And it's divided by 0. But this example is also divided by 0, but there is the limit of 1 over 6. Calculus is about being very particular, right? The devil is in the details. So be very particular and make sure that you compute these things. The less you memorize, the better off you are, because your analytical skills are going to kick in to survive, right? Hold on. So, as soon as you see 0 in denominator, disregard plug-in method. But it doesn't tell you anything about the limit does not exist. You actually have to go on and keep computing. Rationalize, factor, cancel, identities, a lot of different things that you can do. Let me give you an example that you are going to absolutely hate. Limit x goes to 0 of sine x divided by tangent x. Yay for the trig. Who's still with me? Both of you, huh? Okay, good. So we have a sine divided by tangent. So you use plug-in method. Sine of 0 is 0, and tangent of 0 is 0. You can see that from the graphs, right? The sine of 0 at the origin is 0, and the tangent as well goes through 0, 0, right? It has this asymptote. It looks like x cubed, but it has asymptote, so it's not x cubed. So they both go through 0. So method doesn't work, right? Plug in. Nah, plug-in does not work because we got divided by 0. But as I said, you don't get to write. You don't get to write does not exist. You have to see what you can do with this. So now it's identities time. What's tangent equal to? Beautiful. So limit x goes to 0 of sine x divided by cosine x. If you follow, remember that you have to put this limit on every step? Yeah, good. Well, it's either that or -1, you pick. So now you have sine x over 1 times cosine x over sine x, right? Because this line over here is the division line, right? That's divide, and to divide two fractions, you flip the second one and you put multiplication. So now you see that the sine cancels, and you just have cosine. But what's cosine of 0?
1.
There we go. So in this case, 0 divided by 0 is 1. There's going to be some very interesting conversations tonight when you go and have your dinner, right? And you can always start from, did you know? So there you have it. Let's see another example. How about limit x goes to what? 7, thank you. Of seven. Nope. I want to fix this. Perfect. There you go. Okay. So now what? Shall we plug in? Do we get 0 over 0 immediately? Yeah, we do, right? Plug in does not work. So, what should we do? Ooh, nice. Or multiply by the conjugate. So, yeah, you have some ninja skills that over there. Yeah. Because that's the next level.
All right.
So what we have there, no, that's perfect, because that's exactly what we're going to do as well. So when you have square roots, you are programmed to rationalize, to multiply by the conjugate, which is the square roots with a different sign in between, right? So you want to multiply by root x plus root 7 over root x plus root 7. Right, so if you multiply, you will be able to complete this problem. Don't forget the limit. X goes to 7. Now, in the top, in the numerator, you have difference of squares. So root x times root x is x. Then the cross ones cancel, and you just have minus 7. I will link the formula that I used. The formula was a minus b times a plus b to give me a squared minus b squared. So that's the formula I used to jump immediately without foiling all 4 terms and so on. Now on the bottom, I'm not going to multiply anything. I'm just going to leave it because I see I can cancel, right? So now these guys cancel, and I have limit x goes to 7, no coughing, is 1 over square root of x plus square root of 7, which is 1 over 2 square root of 7. So we just use rationalizing from the list. But we can be fancy. Let's be fancy. Let's employ some mathematical gymnastics over here. Orange to stand out. Other way. So this is something that you will usually not see in your algebra class, but it's possible. Limit x goes to 7 of square root of x minus square root of 7 divided by x minus 7. You know the trick? The trick is to?
I don't know if I know the trick.
You said it.
Say the denominator.
Factor denominator, exactly.
Factor, so it's root
Yes,
x plus or minus 2, 7.
exactly. So we are going to use this formula here. Now you are used to use this formula only on squared numbers and squared, right? But you can use it on anything because you have square root available. So you can, like if you, in your algebra class, you had x squared minus 100, and those were perfect squares. So you would have x minus 10, x plus 10, right? That was your algebra. But now I'm saying that you can use this on x minus 3, because you can just have root x minus root 3, root x plus root 3. Would you agree? It's the same thing. You never considered factoring like that before. Well, you'd have, but right? And it wasn't it was not presented in your algebra class at all. but it's in domain of what we can do. So, limit root x minus root 7 divided by, and now we factor root x minus root 7, root x plus root 7, and now you see that these guys cancel, leading immediately to the same answer as before. Now we just cut out a few steps to get there. So it's equal to 1 over 2 root 7 again. It's quick. So it cuts out a lot of the foiling and multiplication of roots and all these kind of things, if you know these kind of cool tricks. So this is just a note on a side, as I promised, right, to kick in with algebra and pre-calc as necessary. So cool note. There you go. Bye. And we have the formula that drives that in blue up there. Good. So these are all different methods and computes and in computing the limits. We still have to talk about limit laws, and we have to do a few more things. So we'll finish that off next time, unless you want me to go to the limit laws now. No takers, I see. Okay. Okay, let's write it down then, since no one is objecting. And limit laws is the list of rules and formulas that you can use to solve particular problems, but it's important later in our course. One is the sum, which says that the limit x approaches a of f of x plus g of x. So if you have limit of a sum of two functions, you can separate these into sum of two limits. I don't like this blue, it's too light. Is there a darker version of... Alright, that works. So we'll switch to this one. Oh, but this one won't erase. There we go. Number 2. Difference. Which is limit f of x minus g of x. And it will be the same thing. I'm just going to drop this x goes to a because it's everywhere. Or maybe I won't. Three is the constant multiple. So if you have a number multiplying the function, you can kick that number in front of the limit. That's a really cool thing. Then we have the product and quotient, so almost there. Now, product and quotient will only work for limits. They don't work for derivatives or integrals. I'll stress that a lot when we get there. So f of x times g of x, you can break it apart into limit x goes to a of f of x times limit of g of x. So you can take individual limits and then multiply the answers. Quotient. Same thing. Limit of f of x divided by limit g of x. Number 6, power. Limit x goes to a of f of x raised to the n. You can just do the limit of f of x, and then once you find the limit, that's why it's in parentheses, once you find the limit you can square the whole thing. Not square, n. Could be cube, could be anything else. Now I'm not sure why is this separate line. They call it root. You can just put this m over n over here and be done. It takes everything under it. But they have a separate line for it, so what the hell. Raised to 1 over n is going to be same thing as above. X goes to a of f of x to the 1 over n. So these are all the limit laws, and this is how you split or combine limits into one. So the very quick example for this would be, let limit x goes to, let's say, 3 of f of x. We don't know what f of x is. Let's say that's 8. Limit of g of x is negative 4 as x goes to 3. And let's say limit of age of x, you definitely have problems like this on the homework stuff. Let's say it's 1 as x goes to 3. Compute limit as x goes to 3 for 3g of x plus age of x squared divided by 2f of x. So by using limit laws, you can break this apart into 3 limit g of x plus limit age of x everything squared divided by 2 limit f of x. Now each one of these is x goes to 3, right? And now you just replace the numbers. Be very careful. So limit g of x is negative 4, so I have 3 times negative 4 plus age is 1, so that's 1 squared divided by 2 times f, which is 8. So this is negative 12 plus 1 divided by 16, negative 11 over 16. You're replacing blocks. You have a block for, you see how limit age of x, x equals to 3? So that whole thing is equal to 1. So you just replace the whole thing with 1 and you get 1 squared. You have a block of limit of f of x, that was 8, so 2 times 8. You just replace the entire block with what is equal to. You get 1 or 2 exercises of these just to practice limit laws. These limit laws will be used later. You're not going to use them, I think, anywhere in chapter 2. But in chapter 3, they're going to pop up at one particular spot. So, you know, it's good to have them. Bye.
Bye.